All right, in the last video, we got a lot of practice with the chain rule. If it's starting to feel a little bit better, but still doesn't feel really solid, you're exactly where you should be. Chain rule takes a long time to get comfortable with. What I want to do in this video are more chain rule examples, but I want to show it in its worst possible form. I want to show the chain rule when it's involved with other rules. So when you have, I don't know, like a product rule inside of a chain rule, or a chain rule inside of a quotient rule, or something like that. This is the video where we want to be really careful about how we write things up and really show all of our different steps, because it's super easy to miss something when you have multiple rules within a given problem. So let's take it one step at a time. Suppose we're trying to figure out the derivative of e raised up to the power of x times the natural log of x. All right, this is our problem here. With the color coordination, you might be able to see that e to the x is the outside function. And as we talked about up here, a nice little shortcut is when you're taking the derivative of e raised up to any stuff, your answer is e to that stuff times the derivative of that stuff. So all I got to do down here to take this derivative is write e to the x natural log of x, and then multiply that by the derivative of x natural log of x. Bad news. The derivative of x natural log of x, that's not something that's immediately apparent. You need a special rule to figure this out. If I had just asked you what's the derivative of x natural log of x at the start of this video, you'd probably be good with it. But when you see that inside another rule that's already kind of complicated, it can be really hard. Enough stalling. Can you kind of see how the product rule comes into play here? My final answer would be e raised up to the x times the natural log of x times, and then using the product rule, the derivative here is the derivative of the x, which is just 1, times, leave the natural log of x completely alone, and then add to that the derivative of natural log of x, which is 1 over x, times, leave the x completely alone. The calculus is done at this step, but if you want to clean things up, you can. We get e raised up to the x times the natural log of x power times the natural log of x, because 1 times natural log of x is just natural log of x, plus 1, because 1 over x times x is just 1. I'd probably call this good here and move on to the next example. The next example is a lot like the example that we just did. In the example we just did, we started out with the chain rule, and then inside the chain rule, there was a product rule. In this example, we're again going to start out with the chain rule. We got something raised up to the 5th power, but then inside that chain rule, the something that's being raised up to the 5th power is a quotient, 3x plus 1 over the log base 4 of x. We got a quotient rule inside of a chain rule. Is that something you can deal with? If so, it's pretty impressive. I first want to take the derivative of the red layer. I get 5 times something raised up to the 4th power. I want to leave that something completely alone, 3x plus 1 divided by the log base 4 of x. And then when I will multiply that by the derivative of that something, 3x plus 1 divided by the log base 4 of x. The calculus is done over on this side. I'm done with my chain rule. All that's left is the calculus over here where I have a quotient rule. When I'm taking the derivative of a quotient, I end up with a quotient as my answer. What goes up on the top is the derivative of the top here. So the derivative of 3x plus 1, which is just 3, times the bottom, which is the log base 4 of x, minus the derivative of the bottom, the derivative of the log base 4 of x, which is 1 over x times the natural log of 4, times the top, which is 3x plus 1. And then I'm not done. I need to divide that by the bottom, log base 4 of x squared. Could you simplify this? Yup. Is it worth your time to simplify this? I'm kind of leaning towards no. I think maybe we'll call this one good. It's not great form to leave fractions inside fractions, but my focus of this video is less on the algebra and more on the calculus. So for that reason, I think I'm going to stop right here and call this my answer. What else you got? Look at this problem. This problem's kind of crazy. If you can see why this problem is so crazy, that's really impressive. What we have here is a chain rule inside of a chain rule. Wait, what? I don't see it. Let me show you the different layers. I'm taking the derivative of 5 raised up to some power. There's my outermost layer, the 5 raised up to this stuff. What is that stuff? That stuff is the natural log, but not of x, of something else. My next layer is the natural log stuff. My innermost layer is x squared plus 4. I got a chain rule, blue and green, inside of a chain rule, red and this blue-green thing. Oh man, that's going to be super hard. Well, it turns out it's not. It's just an iterative process. You do the same thing you've been doing, just peeling off the outermost layer one step at a time. Let me show you. When you're taking the derivative of 5 raised up to some power, that derivative is 5 raised up to that stuff times the natural log of that base, the natural log of 5. If it was the derivative of 5 to the x, my answer would be 5 to the x times the natural log of 5. But it's not. It's the derivative of 5 to some stuff. So my derivative is 5 to the stuff times the natural log of 5. It's a lot like this case up here. I've done this part of it. I still have to multiply by the derivative of that stuff. I'm still not done. I need to multiply this by the derivative of the natural log of x squared plus 4. What's the derivative of the natural log of x squared plus 4? Pretend this is a brand new problem. Pretend we hadn't done anything else. You just walked in and saw this written on a chalkboard or something. Could you figure out this derivative if this was all it was? I bet you could. I bet you could see the outside layer and the inside layer and use the chain rule to figure that out. And the good news is if you can figure that out, we're done, right? Because the only d over dx left is this one right here. So yeah, we've had to do some work to get to that point. We peeled off the 5 layer with all of this stuff, but then what's left is just another chain rule. I got all this stuff in red times the derivative of, if it were natural log of x, it would be 1 over x, but it's not. It's the natural log of x squared plus 4, so it's 1 over x squared plus 4. Then you're done? No, I still need to multiply by the derivative of the x squared plus 4. The derivative of x squared plus 4 is 2x. Here's kind of taking care of the outermost layer. Here's kind of taking care of the second layer. And here's taking care of the third layer. Chain rules inside chain rules is something I find incredibly fun, and you may or you may not. But whether you enjoy it or not, it's certainly doable, and it's something I want you to be able to do for this class. Example C is a good one. Let's do one more and then I'll call this video good, and I have a few extra topics to throw in, but I'll do that in another video because I know how intense these are in this section. Look at this thing. This looks horrible, right? What you want is the skill to be able to look at this and see what's going on. It's the derivative of something, x to the 4th, times something else, the natural log of 3x cubed minus 2x squared plus 1. The outermost layer here is the product rule. Inside the product rule, we might have to involve other rules, but the first thing you want to be able to see here is the product rule. So if I'm using the product rule, what I do is I take the derivative of the first thing, the x to the 4th, and then I multiply that by the second thing, the natural log of 3x cubed minus 2x squared plus 1. And then I add to that the derivative of the second thing, so the derivative of the natural log of 3x cubed minus 2x squared plus 1 times the first thing, the x to the 4th power. No chain rule, nothing new here. This is just the product rule so far. There's 2 of these d over dx symbols. One over here, that'll be easy to take care of. One over here, that'll be a little bit more challenging. Over here, the derivative of x to the 4th power is just 4x cubed using my power rule. So I get 4x cubed times the natural log of 3x cubed minus 2x squared plus 1. What about over on this side? Can you see a chain rule here? Can you see what the outer function is and what the inner function is? If you were color coordinating this, could you write some of it in red and some of it in light blue? If so, you can figure out this derivative. The outermost function is the natural log of the stuff. The derivative of natural log of the stuff is 1 over that stuff, 1 over 3x cubed minus 2x squared plus 1, times the derivative of that stuff. The derivative of that stuff is 9x squared minus 4x using the power rule on this inside stuff. The derivative of the natural log of 3x cubed minus 2x squared plus 1 is what you see right here. Don't forget we had an x to the 4th power tacked on at the end, so that falls down here. No derivatives, we're just taking the derivative of these parentheses. This came from our product rule earlier. We're all out of d over dx's, so we're done with this problem. I would probably take all this stuff and put it on the top of the fraction and maybe even get rid of these parentheses. Guess I might as well do it. I'd leave this first term completely alone, but this second term, I take to the x to the 4th and distribute it through to get 9x to the 6th minus 4x to the 5th. That's this distribution. And then I take all that stuff and I think about it as all that stuff divided by 1, which makes it make sense to put it on the top of this fraction, where 3x cubed minus 2x squared plus 1 is the denominator. I'd probably stop right here. But if you stop right here, that's totally fine. If you can get chain rule inside product rule, you're dominating this chain rule section.